Have you ever wondered how inductors work in a circuit? Well, that's the question we're going to explore today. Inductors, those seemingly simple electronic components, have a fascinating and critical role in the world of electronics. Inductors are like the unsung heroes of a circuit, quietly doing their job, often unnoticed. They store energy in a magnetic field when electrical current flows through them, and this characteristic is utilized in a myriad of ways, from filtering out unwanted frequencies to converting direct current into alternating current. Understanding inductors is essential for anyone passionate about electronics. They're like the secret ingredient that can make your circuit work just the way you want it to. In this video, we'll delve into the principles behind inductors, see them in action, and highlight key things you need to know about them. We're about to embark on an enlightening journey into the world of inductors. Stay tuned as we unravel the mystery of inductors. Inductors, at their core, rely on a simple principle. Now let's break this down. Imagine a conductor, just a simple wire. When an electric current flows through this wire, it generates a magnetic field around it. Simple enough, right? But here's where it gets interesting. If we take this wire and coil it into a loop, the magnetic fields from each turn of the wire overlap, amplifying the overall magnetic field. This is the basic principle of inductance. A stronger magnetic field is created with each additional loop of wire. An inductor, then, is essentially a coil of wire designed to take advantage of this principle. When an electric current passes through the coil, it stores energy in the form of a magnetic field. This energy can be released back into the circuit when needed, making inductors particularly useful in a variety of electronic applications. So, the magic of inductors lies in their ability to store energy in a magnetic field when electric current passes through them. Now that you know the basic principle, let's see how inductors work in a circuit. Inductors, those spiral coils of wire, have a fascinating job in a circuit. They oppose changes in current, acting like an electronic inertia. Imagine you're driving a car. When you step on the accelerator, the car doesn't instantly reach its top speed. It takes some time to get moving. That's inertia. Similarly, an inductor resists changes in current, allowing it to gradually increase or decrease. Now let's talk about direct current, or DC circuits. In these, once the current reaches a steady state, the inductor behaves like a short circuit, allowing the current to flow freely. But when it comes to alternating current, or AC circuits, the story changes. Here, the inductor's opposition to changing current, what we call reactance, becomes crucial. The reactance increases with frequency, making the inductor act like a high-pass filter, allowing high-frequency signals to pass while blocking those of lower frequency. This ability to control the flow of current based on frequency makes inductors incredibly useful. They're found in filters, where they remove unwanted frequencies, and in transformers, where they facilitate the transfer of energy between circuits. From noise suppression in audio systems to power regulation in electrical grids, inductors are everywhere. They help us tune into our favorite radio stations and even make electric guitars possible. From filters to transformers, inductors play a crucial role in shaping the world of electronics. It's time to wrap up what we've learned about inductors. Inductors, as we've seen, are vital components in electronic circuits. They store energy in a magnetic field when electric current passes through them. This unique property allows them to resist changes in current, making them essential for regulating power flow. Their applications are diverse and widespread. You'll find them in everything from simple radio receivers to complex computer systems. They're the unsung heroes of the electronic world, operating quietly in the background, ensuring everything runs smoothly. Remember, the key to understanding inductors lies in their basic principle. They resist changes in current. This simple idea underpins their function in a multitude of electronic devices. Mastering the concept of inductors is a significant step in your journey into the fascinating world of electronics. It's a challenging subject, no doubt, but with patience, curiosity, and a bit of tenacity, it's well within your grasp. And there you have it, a crash course on how inductors work in a circuit. We've covered a lot today, haven't we? From the basic principle to seeing inductors in action and key takeaways, it's been a wild ride. I appreciate you sticking around, and I hope this has added to your understanding of electronics. If you found this useful, do give us a thumbs up and subscribe to our channel. We've got plenty more content coming your way to make learning electronics engaging and enjoyable. Remember, every like and subscribe helps us create more educational content for you. So join us in this journey of discovery, and let's make learning electronics fun and engaging.